Hello everybody, welcome back to another episode with Omar Bakry. And today I'm going to be talking about periodic trends. So many of you might ask, what are periodic trends? Well, periodic trends are specific patterns in the properties of chemical elements that are revealed in the periodic table of elements. I'm going to be talking about 6 today, and these 6 are going to be electron affinity, proton pulling power, ionization energy, atomic radius, electron shielding, and ionic radius. So let's get on with the video, and I hope you guys enjoy it and understand. Oh, hey guys. So, as I was mentioning before, I'm going to start off with electron affinity. So what does electron affinity actually mean, and what happens to it in the periodic table? Well, electron affinity is defined as the change in energy, which is measured in kilojoules/mole, of a neutral atom in gaseous phase, when electron is added to that atom to form a negative ion. In other words, the neutral atom likelihood of gaining an electron. So, as you can see in this periodic table, we can see, I'm going to explain now. Electron affinity increases going upwards and increases going from left to right. So many of you might ask me, why does this happen, Omar? Well, that's a good question. And the answer to that is, it increases from left to right and from down to up because the electrons added to energy levels become closer to the nucleus. Thus, a stronger attraction between the nucleus and its electrons. So as there are more electrons added, it forms a closer bond with the nucleus. Therefore, it increases it from left to right. Now let's get on with our second one, which is electronegativity. Hey guys, it's me again. So now I'm going to be talking about electronegativity. So what is electronegativity? That's a really good question. Electronegativity is the measure of the tendency of an atom to attract a bonding pair of electrons. The Pauling scale is most commonly used. Fluorine, for example, is the most electronegative element. Now, in general, electronegativity increases across a period. So, from left to right, it increases. It increases because the number of charges on the nucleus also increases. That attracts the bonding pair of electrons more strongly. So, they're more strong as they move from left to right. As you go down the group, electronegativity decreases because the bonding pair of electrons is increasingly distant from the attraction of the nucleus. So now that I have explained electronegativity and affinity, let's get on with ionization energy. So, ionization energy. Ionization energy is the energy required to move an electron from a gaseous atom or ion. The first or initial ionization energy is known to be E1 of an atom or molecule. It is the energy required to remove 1 mole of electron from 1 mole of isolated gaseous atoms or ions. As a result, it is easier for valence shells to shell electrons to ionize, and thus ionization energy decreases down the group. So as it's going down, it decreases. Electron shielding is also known as screening. The ionization energy of the elements within a period generally increases from left to right. This is due to the valence shell stability. Now let's get on with ionic radius. Hey guys, now we're going to be talking about ionic radius. So what is ionic radius? Ionic radius is the measure of an atom's ion in a crystal lattice. It is half the distance between two ions and barely touching each other. And an ion has an additional electron, which increases the size of the electron crowd and makes the ionic radius larger than the atomic radius. So in general, ionic radius, as you move from top to bottom in the periodic table, ionic radius increases. However, when you move from left to right, ionic radius decreases in the periodic table. Now let's move on to the next one. Now we move on to atomic radius. So, atomic radius is a chemical element, the measure of the size of the atoms, usually the mean or typical distance from the center of the nucleus to the boundary of the surrounding shells of the electron. So what happens to atomic radius in the periodic table? Atomic radius decreases from left to right in the periodic table. This is caused by the increase in the number of protons and electrons across the period. So as we go across the period, the number of protons and neutrons increase. So it increases from left to right. One proton has a greater effect than one electron. Thus, electrons are put towards the nucleus, resulting in a smaller radius. Now let's move on to our final one. Now guys, we're on to our final thing, which is going to be electron shielding. So, electron shielding refers to the blocking of valence electron shell attraction by the nucleus due to the presence of the inner shell electrons. Electrons in an s orbital can shield the p electrons at the same energy level because of the spherical s shape. When moving to the right of the periodic table, so from left to right, the number of electrons increases, and that strengthens the shielding of the strengthens the electron shielding as it moves from left to right. So guys, this is the end of the video of Omar Bakry explaining the periodic trends. I hope you understood it, and like, comment, subscribe, and share. And don't forget to tweet me on my hashtag. And yeah, thanks for watching.